Talk to me, Mike.
So I started out, I saw that x equals 3, and I saw that x is greater than or equal to 3 over on the right, and it's 6x minus 9. And then if it's less than 3, then it'll be x squared. And so I just kind of plugged in x for 3. So I did 3 squared, that's 9. So now I know that if it's infinitesimally smaller than 3, or if it's anything smaller than 3, then it's 9. And then I plug it into the other one, and I got 0. So at 3 or higher than 3, I'm at 0. So then I saw that was a jump, I guess.
Okay, pause for a second. Your thinking's pretty good. You are making a mistake. I'll show you that in a second. And then you also really, we want to take advantage as much as we can of preparing for the written section, even though we're doing multiple choice. On the written section, when they start asking about whether a function is continuous or differentiable, you need to pull from your head this flashcard. So on one side of the card it says that, and on the back side it says this. Because on the written section, if you don't use this definition, you will get 0 out of probably 2 or 3 possible points for a question similar to this. So you must use the definition. Because this problem is asking, is the function continuous at x equals 3? The only way technically for the function to be continuous at x equals 3 is if these 3 expressions are equal. That's the only way f is continuous at 3. Is there? What you are doing is more like what I would use if I could see a graph. So I have another flashcard that says this. So that's my other flashcard. I use this flashcard when I am doing a graphical problem. So f is continuous if f has no jumps, removables, or vertical asymptotes. I use this flashcard when I'm doing a non-graphical problem. Because I've learned from experience that on the written section I'm going to have to.
So because they're not equal to each other, that's why they're neither continuous nor differentiable.
Right, because your other flashcard is this. Now you're still making a little mistake, but your thinking's still good, so stay with me. The other flashcard looks like this. F is differentiable at x equals 3 if these 3 are the same. Oh, I made a mistake. We got to fix this. No. The first requirement for being differentiable is the function must be continuous. So the only way for f to be differentiable is if f is first continuous. Don't ever check. Interesting. Don't ever check to see if f is differentiable if you haven't first checked to see if f is continuous. With me? Yes. So what you said was correct. If f truly isn't continuous, there's no need to go looking for differentiable.
Yeah.
Okay? Got it?
Yes.
Awesome. Full ticket for everyone in the room if you want one. Based on that statement, one of those items is never going to be true. Like one of these items, A, B, C, or D, or E, one of those, it's impossible for it to ever be true. It just can't be.
It would be E because
That violates the ticket, but well, whatever. I was trying to
I'm saying
Oh.
the answer is D, but I'm saying is E the one that can never be?
Oh, raise your hand. Show me your hands.
Oh.
Which is the one that can never be true? Like it's impossible. Okay, Ashley. C. I just said that to be differentiable, f must first be continuous. So there's no teenage language freaking way that a function can be differentiable but not continuous. Can't happen. Who knew it? Okay, now let's go. So are you good to there?
Yes.
Okay.
See, look at how cool that snail is. Isn't that
Awesome.
sick?
Sick, is what I was thinking. Sick.
So C is the one that, so I got D for my answer. So C is the one that can never happen ever.
C can never be true because you tell me what's the first requirement for a function to be continuous.
Because it has to be continuous.
Sorry, what's the first requirement for a function to be differentiable?
It has to be continuous in order to become differentiable.
Right. So there's no way for a function to be differentiable but not continuous.
Yes.
Good?
Yeah.
Question?
Well, so the left-hand and the right-hand are the same.
That was his mistake.
They are the same.
Yeah, let's talk about that for a second. No, that I was kind of getting ahead of myself. But yeah, that was the mistake he made. So let's summarize so the people on the video don't get lost. So I read the problem. Now, one other flashcard while I'm doing this. You should also have this flashcard in your deck. Okay. Again, I'm going to use this flashcard when I'm doing a non-graphical problem. I'm going to use this flashcard if the problem is graphical. Okay. So we're supposed to be figuring out if f is continuous. So Mike, what's this limit?
So that's directly to the left of 3. So that'd be 9.
Yep. Because you used which equation up there to find it?
X squared.
Yep. So we need to talk about that. What's f of 3, Mike?
So that's the equal to, so that'd be 0.
How are you getting to 0?
Oh, I'm adding, not multiplying.
That'll do it.
18 minus 9, that's 9.
There we go. And then what's the limit over here?
Also 9.
There we go.
I see exactly where I went wrong now.
So f is definitely continuous. Now we need to check. Oh, question. Oh,
No, I just realized it.
oh, sweet. Now we need to check for the differentiability. Correct. Undefined is kind of a goofy answer because, well, that would be true if there were no equal sign there.
Goofy.
Yeah, that just means you can't find f of 3. So. To find whether the function is now differentiable, I've got to do this check. So I need to know what f prime is. So I take that and I find f prime. Don't ever put an equal sign yet. You never put an equal sign until you verify that this is true, that you can actually find f prime of 3. We don't know yet if we can. Questions? Maybe you need to talk more? So, we good? Say again.
I'm a little confused why you wouldn't, because there already is one.
Gotcha. Let me draw a picture and hopefully it will help. Okay, if f looks like this, I'm not saying f does, but if f looks like this, okay, and this point right there is x equal 3, will it be possible to find f of 3? So f of 3 is the point. And there's a point right there, so there it would be possible to find f of 3. So the equal sign is simply telling us it's possible to find f of 3. With me? This equal sign here would be saying it's possible to find the slope of f at 3. For that picture over there of f, can you find the slope of f at 3? No. So it's possible that we can find f of 3, but we cannot find f prime of 3. That's why we have to leave off the equal when we write out f prime. Is that better?
Yeah.
Good. So somebody, what's this? Good job, you guys.
Thank you.
6. Keep going, Ashley. We don't know that one yet. What's this one? Okay, look up, Cambria. We found that the slope of f on either side of 3 is 6. So is this a valid picture for f? I can't tell by you. There we go. So you gave me a look of like, oh my God, I don't know what that means. So we're okay. If the slope on both sides of f is 6, then we're safe to say that the slope in the
So
middle
if
is
they
6.
were different, then it wouldn't.
Correct, because there'd be a corner.
Okay. So then that means it's different.
Yeah.
Wait, can you just re-explain why the equal sign is on the lower one and not?
So what's the purpose of this formula, Mike?
If we have a point on the graph of f that is greater than 3, we know which formula to use, and if it's less than 3, we know which one.
So using this formula for f, is it possible to find f of 3?
Yes.
Yes. Now this is the formula for finding the slopes of f. With me there?
Yes.
Okay. Here's my picture of maybe what f looks like.
Okay.
Based on this picture of f, can you find the y-coordinate of f when x is 3?
Yes.
Yes, I can see it. It's right there. Is that okay?
Yep.
But now we need to find the slopes of f. So we're going to use the f prime formula. Can you find the slope of f right here at x equal 3?
Yes.
Because it's a corner, you can't. Because the way we find slope,
So
Is-
even with, okay.
whenever we find a slope, what we're doing is we're going to the point of interest, and we're finding a secant to the left and a secant to the right. And we're making those secants really short in order to determine the slope right at the point.
Yeah.
If I go to a corner and go secant left and secant right and make those slopes short,
Straight line.
I'm never going to get them to be the same.
Yeah.
So I can't find the slope at a corner. So if f has a corner, I cannot put an equal sign there. If I put an equal sign here, it means I can find the slope at 3. If there's a corner, I can't. So I check for the corner by checking these two here. If these two are the same, that means no corner, because the slope on either side of 3 was the same. So the slope in the middle has to be the same as well. Because the corner is when these two are different.
So it has to be when it's at 6.
So the slope in the middle would be 6 as well, so I can put the equal sign on. So.
Okay.